Lesson 19, colloids. We will be able to describe what a colloid is. So I'd like you to jot that down if you wouldn't mind. Obviously, we've never talked about colloids, so this is going to be something brand new for a lot of you guys. But I'm hoping that by the end of today's lesson, you guys can tell me what a colloid is, but also give me some examples of colloids. Now, quick question for anyone in chat that wants to answer. Can you guys tell me what is the picture of in the top right-hand corner? It is milk. It's a glass of milk. Good job. Now, here's the question. If we're talking about colloids, why do you think that I've got a glass of milk there? What do you think that these two things have in common? Energy? Sort of. If I'm talking about colloids and then I put a picture of a glass of milk, yeah, it's probably a colloid. These things are probably the same. So milk is probably a colloid, and milk is actually an example of a colloid. It's going to be one of the examples that we talk most about because it's like one of the examples that I like to bring up. So lesson 19, colloids. And yeah, if you missed lesson 17 or 18, again, the advantage is you can at least watch lesson 18 on the Google Classroom. Lesson 17 was done in not Monday, but the Monday before. So that was a while ago. That's when we learned about diluted, concentrated, and saturated. So that's going to be something that you guys will have to look up on your own. But you can use this slides. But before we start this lesson, let's go back. So let's go back to where we were. What did we learn last time? So on Monday, we talked about suspensions versus solutions. So we learned about a brand new type of mixture. A suspension is a brand new type of mixture. So what is a suspension? Before we talked about suspension, we just made sure that we had understood that dilute, concentrated, and saturated, which is too much. You have too much solute, so it doesn't dissolve, and it sinks to the bottom. And then I told you guys that there's saturated, it's where would it go? It would sink to the bottom. I then said, well, okay, what is a suspension? A suspension is when things sink to the bottom. A suspension is when things sink to the bottom. When they do sink to the bottom, it's called sediment. So I said that what is a suspension? A suspension is large particles mixed with a liquid. So the large particles will sink at the At the end, you can see through it. At the start, you can't see through it, but at the end, you can. So example, dirty water, orange juice. We said boba tea as well as an example. Anything where you've got like in orange juice, it's the pulp. The idea is that heavy stuff sinks to the bottom. If I have a glass of water too, and I add sugar, but I add so much sugar that it sinks to the bottom, I no longer have a solution, I have a suspension because I have things that have sunk to the bottom. So then I asked at the very end, we said, well, we showed you guys a picture of glitter. We said the glitter is a suspension. These things sink to the bottom because they don't dissolve in the water, so they sink to the bottom. We drew some pictures, and we said the pictures look like this compared to this. And then what we did was we said, what was the similarities and differences? They were similar because they were both mixtures. but they were different because one was all dissolved, and one was, which is a solution, but a suspension, you know, has some non-dissolved parts. And those non-dissolved parts, they sink. So those non-dissolved parts can be soluble, which means they're dissolved, or insoluble. So before we start to talk about colloids, right, I thought that I'd actually give you guys a chance to test your knowledge. Let's go back to here. Tara's back. Good timing, Tara. Okay, so lesson 19, colloids. We will be able to describe what a colloid is. So let's talk about what a colloid is to start off with. So, colloids. Yep, I saw that. Colloids. The particles are, colloids are the Goldilocks of the of mixtures. The colloids, the particles are bigger than those in a solution. The particles, or the little things, they're bigger than in a solution, but they're smaller than in a suspension. So that makes it interesting. An example of a colloid is milk. Milk is the classic example. Milk has, and I'd like you to write this down here, please, if that's okay. So writing this down. So milk is an example. Milk has particles that are bigger than a solution, but smaller than a suspension. And that has an interesting property. What happens is that because they're bigger than in a solution, they don't sink. They don't sink because they're not big enough to sink. But they're not big enough, they're not small enough to dissolve. So we have a very interesting thing happening. I'm going to keep this up for about another, what do we say, minute? Do you reckon you guys will be able to copy this down in a minute? I'm sure some of you have already copied it down. All right. Oop. You need more time. Well, okay, Sage, what about, you've still got 30 seconds. We need more time after that. Stephen's back. Yeah, I saw Stephen, that's okay. Can I get you to copy down what's written on this slide when you get a chance? No, it's lesson 19, I think. Actually, no, I'm not sure. I've already forgotten what lesson number we're up
to. It's lesson 19.
Yeah, that's what I thought. All right, so that's been a fair bit of time. So that's what a colloid is. Let's talk a little bit about what does that make it look like then. So to do that, we're going to draw this. Oh, no, we're not. We're going to give a definition of a colloid. So this is not what I was expecting. I was expecting this next slide here. Oh, wow, okay. I was expecting the third slide, but yeah, that's right. So a colloid is when particles mix with the solvent and stay mixed. The idea is that particles don't sink or dissolve. which is a little bit odd. Normally, a particle would sink. And that would be it. It would sink to the bottom, and then normally a particle would sink to the bottom, but it doesn't. Or it would dissolve, but it doesn't. So it just sort of like stays mixed. It doesn't change. Another example, like if you're not a fan of milk, is mayonnaise. Actually, all three of these over here on the plate are different forms of colloid. This is, of course, the mayonnaise, but if you look, the tomato sauce and the sweet chili also are colloids. They do not sink. They don't sink to the bottom. You don't have to, you don't have to shake tomato sauce up to make sure that, you know, it's still a mixture. It stays a mixture no matter what. Yes, I'd like you to write this down if that's okay. And then what we're going to do is we're going to talk a little bit more about then we're going to talk, after this, we're going to talk about the differences between what a colloid is and what a solution is and a suspension. But I can already give you guys some hints before we even get there. Can anyone see what happens to the spoon in this picture here? What's happening to the spoon in this picture here? Can anyone see the spoon, the bottom of the spoon? Can anyone see the bottom of the spoon? It went fully into the sauce, and yeah, no, I can't see the bottom of the spoon. I can't see the bottom of the spoon at all. If this was a solution like water or salt water or sugar water, would we be able to see the bottom of the spoon? Yeah. Sage, it doesn't actually matter which one. For all of these are, but if this was a salt water or sugar water, or, you know, we'd be able to see the bottom of the spoon. But because this is because this is a colloid, we can't see the bottom of the spoon. That's an interesting point. I'm going to bring that up in the next slide. All right, I'm going to change the slide in 30 seconds from now. If you guys haven't got this down, copy it down yet, then just be aware that in 30 seconds, I'm going to change the slide. Well, it's actually less now, 20. Okay. So, yeah, 3, 2, 1, exactly. So, this is what a colloid is. So let's now talk about, well, what is the difference between a colloid like tomato sauce and a suspension? Let's go with this. The main differences between a solution, a suspension, and a colloid is, in a solution is clear. If I was to shine a light through a solution, you would not be able to see the beam of light. You would just go straight through the water. If you had a laser and you shone it through water, you would not be able to see the laser beam. What about eye drops? Yeah, I think so. I think eye drops are solutions, so you wouldn't be able to see it. Okay. So then next is the next one is a colloid. And the example of a colloid they've used is milk. Now, if you had a glass of milk, right, what you would see is the light would actually go into the milk, and then you can sort of see that the light shows up. You can actually see the light in the milk. See here, you can't see the light beam, but in the milk, sorry, see here, you can't see the light beam, but here you can see the light beam as it goes through the milk. And that's, the light beam is visible. And the reason, what happens with a colloid is the particles are medium, so you can't see through the solvent. You can't see through it. Just like how the light can't easily get through the colloid, you can't easily see through a colloid. You can't easily see through milk. You can't easily see through tomato sauce. It's just the way that things go. The last one is the suspensions. And in the suspensions, the particles will sink and separate. So the idea is that the colloid is between a suspension and a solution. The particles don't dissolve, but they don't sink. So therefore, they just stay mixed. So it stays cloudy forever. And there are lots and lots and lots and lots and lots of examples of colloids. So we're going to talk about a couple of them. And then what we're going to do is we're going to start to work through our bits and pieces. So I'm going to give you guys, let's see, there's a lot of text on this. So I'm going to give you guys maybe a minute from now before I change the slide. If you guys need more time, you'll need to tell me. But otherwise, I'm going to change the slide in a minute. If you've copied this down already, I'd like you to, in chat, tell me something that is liquidy, but you can't see through it. And I'm using the word liquidy because I'm trying to be very, very general here, but what's something we can't see through that is liquidy? Coke. Now is Coke a colloid? No, I'd say Coke is still a solution. Milk tea is a colloid. Tea is a solution. Soft drinks are a solution. Coke. Now the thing is that you might say, but sir, isn't Coke? If I was to get a glass of Coke, right? I can't see through a glass of Coke. And you might say, you know, you can't see through a glass of Coke, but you actually, I want you guys to think about this. The only reason you can't see through Coke is because Coke is black. But that doesn't mean that it's not a solution. Just because it's black, just because it absorbs light, doesn't mean that you can't see through it. If you actually got a laser pointer and you shined it through Coke, it would actually probably go to the other side. Coke isn't cloudy. If you get a thin enough piece of Coke, you can see it. Coffee. Coffee is another solution because even though it's black, you can still see through it. What's something that's liquid that you can't see through? Ranch? Yeah, ranch dressing is definitely a colloid. It's very much like mayonnaise. You can't see through it, so it's a colloid. What's something else that you might have in your kitchen that you can't see through? Think about something you might Soup you can see through. It depends what soup. Oil you can see through. Guys, keep giving me things you can see through. I can see through oil really easily. I can see through soup really easily, unless it's pumpkin soup, which is different. Cleaning detergent. I can see through cleaning detergent. Guys, I'm talking about things you can't see through. Coke you can see through. Soy sauce. Now that's soy sauce. I think you can see through soy sauce. Again, you guys might be saying, no, you can't, but you spread it out. All right. Let's go with, okay, so mayonnaise, milk. You want a list? Here we go. Milkshake. Yeah, sure. Milk, mayonnaise, peanut butter, Vegemite, Nutella, it's a little bit, okay. Someone says peanut butter isn't liquidy. It's a little bit liquidy. Oil, now someone said oil. Oil is a solvent, not even a solution. Oil is a solvent because it doesn't have anything in it. Someone then said chili oil. Now that would be a solution. Lotion, yeah, lotion would definitely be on the lotion. Shampoo. Now, now, what else can I tell you? Toothpaste. Yep, toothpaste is another example. Now, this is the problem that I have with a lot of people, though. They go, just because something is dark does not mean that it is a colloid. Just because it's dark doesn't mean you can't see through it. It's like soy sauce, Coke, coffee are 3 examples. And the reason that I tell you guys that they are not is because you can still shine through. Yogurt is a good example. Can't see through yogurt. Yeah. Cream. Cream is an example. Can't see through cream. What else have I got in my fridge that I can talk about? What about just plain butter? Butter? Yeah. So let's go back over this because hummus. Oh man, I've got some hummus in. Oh no, I don't. I ate all my hummus. But yeah, hummus would definitely be a colloid. You guys are starting to get the hang of it. So let's go look. A solution is clear. You can see through it easily. A suspension has particles that will sink to the bottom. So it's sort of clear at the end, but not at the start. A colloid is never clear. You cannot see through it. And if you shine a light through it, you will see the light show up. The particles don't sink. So that means now we've talked about the differences in words. Let's look at the differences in pictures. So what we're going to do now is I'm going to do we've got 2 pictures here. We've got on the left, we've got a solution. On the right, we've got a suspension, which is, this is dissolved. This is not dissolved and sinking. And in the middle, we're going to add in our colloid. Our colloid is in the middle. It is, as you can see, the particles are bigger than those, but they are smaller than these. They're not dissolved, but they're not sinking. I want you guys to draw this. I'm going to give you guys 3 minutes because there's 3 pictures. So 3 minutes to draw all 3 of these. Large, medium, small. Higher, perfect. That is the idea. And that's why I put this page up here. Because I knew for some people it'd be like, oh yeah, it's like just different sizes and it would make sense when I do them in pictures. When you got the particles, when you got like I've started the timer, so 3 minutes to draw these. So when you've got particles that are really, really small, they can get dissolved. They can mix up really easily. When you've got colloid, when you've got suspensions, the particles are so big that they sink to the bottom. When you've got colloids, they're like, oh, I'm pretty big, but I'm not, so I'm not going to dissolve, but I'm not going to sink. So you can see that so colloids are sort of between the two. They're between the two. They don't dissolve, but they don't sink. So they sort of have properties of both. So what's the difference between a colloid and a solution? They have parts that aren't dissolved. What's the difference between a colloid and a suspension? The particles don't sink. Now you don't have to put too much effort into these pictures. I'm not looking for artistic works of art. I'm just looking for a couple of dots. All right, okay, got about a minute left. And then I'm going to change the slide. We're going to start to talk about some more examples of colloids. All right. So these are the differences. So now what we're going to do is we're going to spend some time talking about, well, now that we know that, what are some examples of colloids? So what are some examples of these types of mixtures? There are many types of examples. There is no pencil here. You do not need to copy this down. So you don't have to copy these down. But there are many types of colloids. You've got sols, which is a liquid plus a solid. You've got emulsions, which is a liquid plus a liquid. You've got foam, which is a gas mixed with a liquid. An example of that would be shaving foam, so shaving cream or whipped cream. An example of a sol would be something like blood or something like milk. An emulsion, oh no, so emulsion, milk is an emulsion. It's like paint or milk. Gels, that's a solid mixed with a liquid, and that's like jelly or like hair gel or like maybe that's where toothpaste would go. I think toothpaste would go there. And then you've got smoke, which is a solid plus a gas. and mist, which is a liquid plus a gas. So there's lots of different examples of colloids. You guys might not think of, when I said give me an example of a colloid, you probably didn't think, oh yeah, shaving cream or whipped cream, because that probably was, because it did tell you that it didn't have to be liquidy. At the start I said it had to be liquidy, but it doesn't even matter.
Oh, Mr. Greer, do we write that down?
No, I said that three times. You do not need to write this down, because instead of writing all of this down, I wanted to try and make this, put this in a way that would be easier for you to write down. So instead of writing it down like this, I thought that it'd be easier. Oh, I'm breaking up a little bit. I'm not sure. Am I breaking up for everyone, or is it just Phoenix that can't hear me?
No, we can hear you loud and clear.
Good. Okay, just double checking. So what I'm going to do is I'm going to change the next slide. And Phoenix, if you can't see it, don't stress too much. We can, you can just copy this down. This is some examples of the different types of colloids. So what are the types of colloids? This is the slide that I want you to copy down. So I thought it'd be easier to do these as a grid. There's less words here. So we've got 1, 2, 3. So this is going to take you guys a little bit of time to copy down, and then we'll go through a couple of examples, and I'll give you guys the last 20 minutes of the lesson to finish off those questions that I gave you at the start. So I'll give you guys, what I'll do is I'll give you guys 2 minutes to copy this down. And then what we'll do is I'll explain it, and then I'll explain how to read this. So we're just copying this down, guys. Got about a minute left to copy this down, but then I'm going to explain it. So if you haven't finished copying it down in a minute, don't stress. But yeah. All right, I'm going to explain how to read this, because this is a weird graph. You might not be comfortable with how to do this. So we're going to do this. We're going to start with solid. So if you put a solid in a solid, you would get a solid sol. And that's an example of a solid sol would be something like colored glass. Colored plastic is also in here as well, but it's just essentially is when you put a solid in mixed with another solid. If you take a solid and you mix it into a liquid, you would get something that's just called a sol. It's like blood. The reason it's the solid, by the way, in blood is the cells, the blood cells, and the liquid would be water. in a then you've got solid in a gas, and that makes something like smoke. In smoke, you've got the solid, which is like tiny bits of wood ash, and the ash is mixed with air. And just like the other rules, right? If you get enough smoke, you can't see through it because it doesn't mix, it doesn't dissolve. Let's look at the other ones. A liquid in a liquid makes something called an emulsion. An emulsion is like when you just got two liquids mixed together. Milk is one, you've got salad dressing, and so on. And then what we've got foam. Foam is a liquid mixed with a gas. You've got foam and mist, both sort of fit in here. And then last but not least, we've got gas. Now, if you take gas and you mix it with a solid, you can get instead of having a foam, you would have a solid foam. The example of that is meringue. If you don't know what meringue is, it's a nice, sweet little treat that's like, it's really airy. I haven't had a good meringue in a while. It's usually the main ingredient with pavlova. Man, I love a good pavlova, but you can just have meringues on their own as well. They're really sweet. So we're going to talk about a couple of these examples, I think. So let's grab a look at some examples. Here are some of the pictures of different types of colloids. I'm going to skip this here for a second, and I'm just going to talk about, so we've got 3 slides left. So we're going to, and most of these slides are just pictures. Okay. So let's go with this one first. This is pretty much the same thing that we just did before, but I'm doing it again. If you don't want to write this down, I actually don't mind if you don't have to, but I want to give you guys, but I want to put this down just so that you've got this information. The first is an aerosol. So these are colloids in gas. There are 2 ways you can get colloids in gas. You can get an aerosol, which is a mist, which is a liquid in a gas. An example is spray cans. So you could have, like, if you guys use Lynx body spray or Axe or anything, then this would be a spray here, but also like something like even like toilet spray would be here. Yeah, I'd like you to write this down if that's okay. What time is it? Because what that is a liquid mixed with a gas. So when you spray, and you might notice this, is that when you spray, if you spray like a liquid, if you spray like toilet spray, or if you spray Lynx, and it hits like a wall, or if it, or maybe Dove antiperspirant or whatever, if it hits like a wall or glass, you might see some little bits of liquid. And that's because there is liquid inside of the spray. That's why it's, but it's, when it comes out of the can, it's an aerosol, it's a mist. It is a colloid, because they're 2 things that are mixed together, but they don't dissolve. Sorry, someone's saying so. Yep.
Did you say we have to write it?
Yes, please.
Okay.
So I'll keep it up here for a bit longer. Smoke is another example. I've already talked about smoke, but smoke is solid in a gas. Let me look up online. I want to see if there's any other examples of solids in a gas. I think smoke is the only one there. Oh, there you go. Another example of this is dust. You guys have ever picked up an old dusty thing and blown it, the dust gets in the air and it's really gross? That is an example of a colloid, if a dust in air. Let's change the slide in about a minute. I know that you started a bit late, so if you haven't got all of this copied down, don't worry. Most of this you would have already written down in the previous slide anyway. I'm just giving some more examples in these next 3 slides, just because some of these words are new. I guess while you guys are copying this down, the last thing I'll do is just talk about this aerosol. This actually comes from the 2 word aero, which is air, right? And sol, which is like a, essentially it just means like a liquid colloid. So it's like an air liquid. So that's what that aerosol means. It's an air liquid, which makes sense. It's a liquid in a gas. That's called an aerosol. Okay, let's move on to the next one. So the next one is colloids in a liquid. There are 3 types of colloids in a liquid. You can get a sol or a gel, which is like paint or jelly, peanut butter, jam. Does anyone here like jam? I like raspberry jam. Not a fan of, well, I don't know. I'm like, do you guys prefer raspberry jam or strawberry jam? Strawberry jam's a bit sweeter, but I don't know. I like a good raspberry jam. Yeah, of course, Mutab likes strawberry.
Mister,
Yes.
do you write that down too?
Yes, please, describe. There's a pencil. So I'd like you to write this down too, please. I also like strawberry. Okay. There's also black blueberry jam. I don't know about blueberry jam. I'm okay with blueberry jam, but yeah.
Mister,
Yes.
if there is a pencil like on the thing, does that mean you have to write it down?
Yes.
Okay.
So if there's no pencil, I'll tell you, you don't have to write it down, but I'll also usually say you don't have to write this down. Yusreb, what about you? Do you like jam?
Yes.
What jam's your favorite? What's your favorite? Apricot, strawberry, raspberry, blueberry. What jam do you like?
Strawberry.
Okay. The weirdest one for me, right, was the other day. I was waiting in line and I saw a jam. It was carrot jam. Jam made out of carrots. And that's the thing, carrots are relatively sweet, but I was like, a jam made out of carrots? I'm like, I took a photo of it because I was like, this is the weirdest thing I've ever seen. I don't know why you would use a jam made out of carrots, but it exists. You can buy carrot jam. I was really surprised and confused. Now, next, underneath jam comes foam. Now, foam is when you take a gas and you mix it with a liquid. Obviously, you can get whipped cream and soap bubbles, shaving cream, any sort of, even like nowadays you can actually buy I have tried marmalade jam. It's not my favorite kind of thing. I've tried apricot jam and I don't like that either. You can actually get, by the way, well, nowadays you can actually get soap foam, which is new. That used to not exist when I was growing up. But yeah, the whole thing when you push down and the soap comes out, but it's all this foamy stuff instead of a liquid. That's, yeah, marmalade is disgusting. I don't like marmalade that much. I'm glad we all agree. Now, one that we haven't discussed is cranberry jam. Now, cranberry jam you only really use if you're going to make like something with like a roast turkey, but cranberry jam is really good too. Yeah, there's a flour soap thing on TikTok. I think I've seen that where they get the soap and it makes little shapes of like flowers. I think, is that correct? This became a jam lesson. Yes, it did become a jam lesson.
It's like flour. It's a flour, and you have to press down,
Yeah.
and there's a flour imprint on your hand.
Yeah, and it makes little soap flowers and stuff. I want to show you guys something at the end of this lesson. Actually, it's completely unrelated, but you know, I will show you at the end because it's kind of cool. It did go from, well, that's the thing is like, I mean, someone's going to went from science to home tech, home ec. It did, the thing about science is that all of these things are, yeah, related. You guys, and like, the thing is like, you can make emulsions and then you can make, like all these things are like, this is linked to food because it's linked to culinary stuff. It's all about the texture. The texture of a jelly or a gel is different from a liquid. So I've seen people get like boba pearls and they put soup inside of them because they're putting a liquid inside of a gel to make it sort of like taste like a different texture. You're biting down onto tomato soup. No, science is everywhere. Thank you, Teresa. Last one here is liquid emulsion. So a liquid emulsion, that's when you take a liquid and a liquid. Mayonnaise and milk are two classic examples of those. So these are when you've got, the whole thing is liquidy, but yeah, milk is a very good example there because it's like you can't see through it. So it's like, okay. But it still sloshes around. Right, let's move on in about 30 seconds. If you haven't copied all of this down, there's a lot on this slide, I know. But, you know, we've got to move away from jam. We've got to move to other things. Now, if you like jam, oh, man. Mr. Greer makes homemade scones. Oh, I love a good scone. You don't know what a scone is? I don't blame you because it's a very English kind of thing to do. But what a scone is, it's like this sort of like it's just pretty much flour and milk, and then you add, and then on top of it you put a little bit of butter, and then you put some jam of your choice, and then you put some whipped cream on top. So if you will, if you want, if you look at scones, right? Scones are a mixture of 3 different colloids. We've got jam, which is an example of a colloid. We've got butter, which is an example of a colloid. And then we've got whipped cream, which is another example of a colloid. So we've got actually 3 examples of colloid. I love a good scone. I know that probably some of you guys aren't a fan of scones because, you know, like You know, it's a very English kind of thing to eat, but still. Last is solid foams, colloids in solids. When you take a colloid, you mix it with a solid, you can get solid foams. An example of a solid foam is a gas in a solid. You can get polystyrene foam. Marshmallows are also a form of a gas mixed in with a solid. And the last one is called pumice. Now, I don't think many of you guys will have heard of pumice, but I'm sure there's someone here that's heard of pumice. Pumice is the volcanic rock. It comes out of volcano. And yes, I'd like you to write this down, by the way. So a volcanic rock, and because it has lots of air bubbles in when it's molten rock, the air mixes with the solid and you get this really light rock. It's a really airy kind of rock. Now, you guys might not have seen it, but some people, I know my sister-in-law, my wife's sister came down, and she had this pumice stone for exfoliation. Exfoliation, for those of you that don't do proper skincare, is the removal of dead skin. So you can actually, like, because you don't want that stuff around, it's a bit gross. So you rub this on there and it breaks away the dead skin. So that's what pumice is. But it's a volcanic rock. You can't just look at it for being cool. Some people. The other one is, of course, solid sol. Now, a solid sol is something like a colored glass, as an example. It's a solid mixed with a solid. But it doesn't really fully dissolve, so you get this colored glass. But that's colloids and solids. Let's keep this up for a minute, and then we'll change the slide because I want to give you guys some time to finish those questions. My hands are dying. I know. I'm sorry, Sage. I know there's a lot of writing today. Don't worry. There is. Wait, hold on. Okay, there's no more writing after this. Once you've got this down, you've got no more writing. You've got a little bit of clicking to do, but no more writing. So that's good. Some clicking is a little bit easier. Phoenix. I'm just reading your thing that you just wrote in chat. I can read what you've said, but you've spelled that word like really, like, completely wrong. Saying that, I wouldn't know how to spell it correctly even if I wanted to. Unconscious. I would say yes. I would definitely say that is sorry. Thank you very much, Miss, pointing out it. You've done well in being able to give it a good try, and you managed to make it so I can understand what you were trying to say. So in many ways, and I can't really correct you because I can't spell it. I'm just trying to spell it now. Unconscious. No, I can't spell it. It's too hard. No. Okay. Nah, she's trying to say her hands are unconscious. But I can't, but I don't know how to spell it either. I think it's something like this. I'm not sure. Anyway, doesn't matter. So last but not least, so I'm going to change the slide. Can I change the slide? Is that okay? Is there anyone that's like desperately trying to get the last little bit down? Nope. All right. No way. Tara, is that yeah, I mean, yes, Tara, do you need a little bit more time? I'll give you a little bit more time. I'll give Tara another 30 seconds or so. Now, And meringue is quite tasty actually, but it dissolves in your mouth as well because it's mostly just sugar dissolved in air, which is kind of what it is, well, mixed with air. That's why it's so light. One more random fact because I've got to stall for time for Tara. Back in the old days, what they used to do in film sets is they used to be like, I think it was like on Hercules, they used to use pumice. So they used to get Hercules to pick up big, massive boulders, and it would make him look really, really strong because he's picking up a big, massive rock. But because it was pumice, it was really, really light. So because it was filled with air, because you can see all these holes are like air holes. So it made him look really, really strong, but in reality, he wasn't that strong because he was just picking up like an airy rock. So that's my last fact. So let's slide I'm going to look at is this. You guys tell me, what type of sol? You do not need to copy this down, yes, Rev, because you see that there's no pencil here. You guys tell me, what kind of colloid is bug spray? What is the name of that colloid? Go back through the page you just written. What is it? Is bug spray a solid mixed with a gas mixed with a liquid? Is it it's a gas and a liquid. Yes, correct. And what is the name of a gas mixed with a liquid? What is that called? Well, it's actually a liquid mixed into a gas. What is that called? What is a liquid mixed with a gas called? An aerosol. Thank you, Teresa. It is called an aerosol. If you said mist, then that would be correct too. How did I know that? If I go back to here, if I go a liquid mixed in a gas, I get a mist. Also, you could look at this. You go here, liquid in a gas is an aerosol. So what would blood be? What is blood? What type of liquid in a solid? Yep, that's correct. That is called a sol. You are correct. It is just called a sol because it is a liquid and a solid. Specifically, a solid in a liquid. That's how you get to sol. Last but not least, liquid soap. What would you say liquid soap is? What is it a mixture of? Liquid soap is probably a liquid with a liquid. So what would that be? What would you call it then? What would it be called? A liquid in a liquid. Go back through your pages. What is liquid soap? What would it be called? It's either going to be an emulsion or I would say, well, no, it's not going to be a foam because Teresa, a foam is a gas in a liquid. We've got liquid soap. So it's probably just going to be an emulsion or maybe a gel because it may be solid with a liquid because if you think about soap is a little bit harder. So it might be a solid with a liquid, but it's going to be one of those two.